With my great pleasure and honor to meet you again and discuss with you about the flavonoids in MR spectrometry. Let us start with a skeleton of flavonoid. We call it C6C3C6, which is benzobiranone, and it attached with aromatic moiety. And when we go to numbering the system, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and here 1 dash, 2 dash until at the end. If we look to the NMR, proton NMR spectra, as we discussed before, the chemical shift is between 1 to 15, and here is aliphatic region until 6.2, then aromatic region, and between 8.5 until the end is a functional group. And regarding integration, you will see that this is 2 proton, for example. This is 1 proton, which means that the number of protons carried by hydrogen. If we look to the skeleton, we will see that at 6 and 8, they are de-shielded due to hydroxy electron donating, and as well as mesoxy is electron donating. Here as well, mesoxy is electron donating in ortho position. So you will see AP spectrum, and you will see the difference in chemical shift here. Of course, the aromatic mesoxy in the aliphatic region and 3.8, which is very much de-shielded of the methyl group due to attachment to oxygen and further to the aromatic moiety. Then it comes 3 dash, 5 dash, so you see, and the other is 2 dash, 6 dash, you see, how much is the difference in the chemical shift? That's why we love to work with NMR, and furthermore is a functional group, which is hydroxy. If we go to carbon 13, now we can also think together that here is the aliphatic region, then comes the aromatic region, and at the end is a carbonyl group. We have only one aliphatic, which is the mesoxy attached to the aromatic ring, and you will see it at 55. And here is a chloroform. Then it will start, so aromatic methoxy, then it starts to the aromatic proton carried by hydrogen, carbon 8, carbon 6. Then it comes 3 dash and 5 dash, right? C10, C1 dash, and 2 dash, 6 dash, 3, carbon number 9, carbon number 2, carbon number 5, carbon 4 dash, carbon 7, and carbonyl group. Here you can practice with such assignment to learn more about the assignment of carbon 13 of flavonoid, which is a strong evidence of the structure. And you could see also the amplification to see clearly the assignment, as well as here regarding C8, C6, 3-5- and 2-6-. Right? If we go to the assignment using Hsqc, and Hsqc means the assignment of proton, which will be correlated to carbon. So if we know the proton, like methoxy group, then we could assign the carbon 13. Like, for example, furthermore, if we know about the C8, for example, then you can do the assignment C5-, you can see the assignment as well, 5- here, etc. So if you know the assignment of proton, you can deduct the assignment of carbon 13. Of course, you must consider that in Hsqc, you see only the correlation between the proton and carbon. It means that you must have proton in the carbon. If you see here, for example, you will not see anything in Hsqc, and in this case, you will need HMPC. Additionally, you can see also the Hsqc, which means the correlation between proton and the proton. Let us see here, 1 square. It means that these protons are adjacent to each other, right? Because it makes such a square, and this is the case, right? You will see as well here, the correlation here, which means that 6 and 8. However, they are in meta position, but because it is 500 megahertz, then you can see the correlation. And of course, the coupling constant here, you can see is very, very little between 1 to 2. But here the coupling constant which is J coupling, you will see it is about 7 to 8. It means that you have this as ortho coupling, right? But this is at meta coupling. So it is logic to have the coupling constant here about 7, 8, but the coupling constant here is very little, 1 to 2. We can go to HMBC, which it shows the correlation between proton and the carbon, even the carbon at the third bond. So let us take this hydroxy group, then you will see that it correlated with C6, C10, C5, C7. So you can go further with each proton to see all the surrounding carbons in the same way. And that's why we call it multiple bond correlation. It means that the hydrogen will be correlated to multiple until 3 bonds of the carbon atom. Then we can deduct the structure. If we go to another kind of spectra, look with me, and we start to guess what kind of compound do we have. Here is the aliphatic region until 6 months, then the aromatic region. And immediately, now I can hear you, that here these two must be AB spectrum. It means that we have also coupling, because the coupling constant is rather big. And here you will see that it is meta coupling, because the coupling constant is very little. Coupling constant means it has doublet. You see, it's very difficult even to see it is doublet. But here it is clear doublet, which means the coupling constant here is also position. It means that immediately we see this is a coupling constant, which is rather high, which is 6 to 8. But here 6 to 8 is meta coupling, which means that the coupling constant is very little. What kind of addition here? In this region, it is the sugar moiety. And what is the approval that it is connected to the structure? It is the anomeric proton, right? It means that the sugar attached to your molecule. Now you can see the assignment. This is the assignment of sugar, right? And then the anomeric proton, very important to assign this, which is at 5.2, right? Then it comes 6, proton 6, which is very much de-shielded between 2 hydroxy groups, right? Then it comes the other proton, then also 2 hydroxy group, right? And finally, meta to the hydroxy group. I think you all agree that we love Proton Nmr since it is really consistent with also physical organic chemistry, that hydroxy group is electron donating group. That's why you see this in the lower delta value, which is shielded, while this is in meta position, which is much more de-shielded, right? Then it comes to the structure, which another compound. Now we can guess about the structure. Again, aliphatic region. And here, now I can hear you. What kind of proton? Yes, anomeric proton. So this is sugar moiety. Anomeric proton means the sugar connected to the aromatic, and then it comes to the aromatic moiety. Now you can see the structure. So this is how you can practice. And what kind of proton? This is methyl group, which means that you have ram nose. This is a methyl group, and it is doublet, very clear doublet. Now you can see methyl group, and then this 2-6-, right? And then the next 6 and 8 protons, right, as usual, anomeric proton, right, and the sugar moiety. Very good example, right? We can go to carbon 13, and it is as usual. You will see first the methyl group, and here is the sugar moiety, then the aromatic proton, and finally is the functional group, which is carbonyl group, right? So methyl group, right? Carbonyl, right? Carbonyl, they're very much de-shielded, very characteristic, right? And then it comes to the aromatic proton, which you can practice with the assignment in like that. And then you can see the sugar units at the end, right? Now we can go to cause spectrum, and we see where is the correlation of the proton, right? See the square? It means that the methyl group is connected to this proton, right? It is of the sugar unit. We agreed that the sugar unit is in this area, and the methyl group is attached to this carbon, right? So this is a correlation, the second correlation in the sugar moiety, and it comes the meta coupling constant. What about the assignment of HMBC? Would you like to practice with some kind of correlation? Now you can see the assignment. If you take, for example, any of these proton, like proton H2 and 6, you will see how much it correlated, H6, H8, etc. So you can practice how we can do the assignment until carbon number 3. Now we can go to another example of this, and this is a Proton Nmr. Now you can see also again that this is the aliphatic region with the anomeric, then it comes to the aromatic proton, and finally is a flavonoid or the aromatic region started from here, right? So you can practice and see the assignment here by yourself, that it matches with all the rules we have been explained before. Carbon 13, it comes, now I can hear you. What kind of assignment in this area? Is a sugar moiety, right? And here, so you can see the sugar, right? And then what kind of assignment? Is the aromatic, and finally it ended with the carbonyl group. So this is, you will see that all this is in the aromatic region. What about this at the end? Yes, it is carbonyl group. So with practice, each time you will learn more and more about the assignment, and here you can do the assignment according, each color is indicated of the assignment of its peak in the carbon 13. With this, I would like to end with the cause spectrum, and you can guess by yourself. These two protons will be ortho coupling, right? And it will give very clear square. This is a reference which we would like to go to more details. And of course, I would like to remind you about collaboration. And I sincerely thank all my team for excellent collaboration and helping with preparing the spectrum. Right? All the very best of luck.